Hi guys, let's take a look at this question where we have 2-point charges A and B, all right? And both of them have a charge of positive 3 times 10 to the power of 9 coulombs, and they are stationary on a horizontal surface. Point P is R meters away from charge A, and point B is 2R meters away from point P. Okay. 7.1. Describe an electric field. So an electric field is a region in space in which an electric charge experiences a force. Please study the definitions out of the textbook. Just study it by heart. 7.2. Draw the resultant electric field pattern due to charges A and B. So I'm going to draw it here. So what do we know about the two charges? They are both positive, right? So they are both positive charges. And what do we know about positive charges? They are going to repel, right? So we are just going to draw charges that are going to. It's going to look something like this, like a spider. Doesn't it look like a spider? So you just draw something like this, and it should be looking like that. So equal amount of lines. They are not touching each other, please be aware, or crossing each other. And don't forget that you have to have your arrows. So with a positive, all of them will be showing outwards. So just write them all outwards. So it should be looking something like that. All right. Your 3 marks will come for showing the correct direction, which I've just shown. The correct shape, which meaning they should not touch each other. All right. And no field lines crossing each other. Then they tell us that the net electric field at point P is 27 newtons per coulomb. And they want us to calculate that little variable. Of course, because they didn't give it to us, right? So we're going to have to calculate. Okay. So, first and foremost, what do we know about the net electric? At point, we know it's going to be the electrostatic force at A minus B or B minus A. So that's what we know so far, right? So I'm going to take A minus B. So then obviously I'm going to have to go calculate that electrostatic force of both. So you can write on your formula of both. Okay. And you jot in your charges. So K is a constant. There we have K is constant, coulombs constant. 9 times 10 to the power of 9. And A's force, they've given us both is positive 3 times 10 to the power of 9, negative 9. The distance that A is to P is R. So it's going to be R squared minus the same calculation on this side, but the only thing that will be different will be the distance between them, because the distance between P and B is 2R. So this will be 2R squared. And they said that our net electric field at point P is 27 newtons per coulomb. All right. So now this will be easy, right? You multiply. And then you multiply to get your R's by themselves. Then you get the square root to get R to be 0,87 meters. So now that is the value of R. Okay. 0,87 meters. Okay. Then in 7.4, they want us to calculate the net electrostatic force that an electron would experience if placed at point E. So if they put an electron at point E, what is the net electrostatic force that it will experience? All right. So there's 2 ways you can do this. I'll show you the easy way. So they want electron. All right. So we can just use this formula. All right. So 7.4. We have the net electrostatic field at point P, which is 27. What is the charge of an electron? The charge of an electron is minus 1,6 times 10 to the power of 19. So I'm just going to put it there. And then I'm going to get 4,32 times 10 to the power of 18 newtons as the force on the electron. Or you could have gone the long route, right, to go calculate. I'll just show you the long way you would have done this by using the standard formula. And Q2 would have been the electron charge, and that would have been A. Then you would have minused B and the electron charge with the same formula. And then you would get an answer of the exact same. All right, guys. And that is it. See ya.